All right. Hello, everybody. We're back with another question. This question is from the Chemistry HL Paper 1 from the November 2020 batch. So this question is asking us, what combination gives the standard hydration enthalpy of Na+? Now, by just looking at this question, and they've also given us the values actually, they've given us the lattice enthalpy of NaCl, they've given us the enthalpy of solution of NaCl, and they've given us the enthalpy of hydration of the chloride ion. Now, just by looking at this, the first thing that should come to mind is the equation for the enthalpy of solution. So the enthalpy of solution is equal to the lattice enthalpy plus the enthalpy of hydration for ion A plus the enthalpy of hydration for ion B. Now, what do these different terms mean? So the enthalpy of solution is basically the enthalpy change when 1 mole of solute is dissolved in excess solvent to form a solution. And the lattice enthalpy is the enthalpy change when 1 mole of an ionic compound is broken apart into its constituent gaseous ions. And the enthalpy of hydration is the enthalpy change when 1 mole of gaseous ions is surrounded by water molecules to form a solution. And as you can see, all of these terms are actually interlinked, and I will show you how they are interlinked. Now, in order to really understand what's happening in this question, we need to first draw a enthalpy cycle or a Hesse's cycle. And this is not necessary. You don't have to do this in the exam, but just so that you can conceptualize and understand what I'm talking about, I'm going to do it over here. So let's just say we have this NaCl. Yeah, it's just common table salt. It's in the solid form. And you decide to go ahead and dissolve it. So now this NaCl in the solid form has become Na plus in aqueous because it's been dissolved, plus Cl minus aqueous because it is also dissolved. And this reaction over here, we're trying to calculate its enthalpy, and its enthalpy is basically the enthalpy of solution, right? But suppose you don't know what the enthalpy of solution is, right? There is another pathway you could take to find out what the enthalpy of solution is. You don't directly have to go from this to this. You can take an alternative route. It's like if you decide to go from your home to the mall and the highway, there's a big jam or a traffic jam in the highway, and you decide not to go that route, you decide to take another route, which is a bit longer, but it gets you to the same destination. This is exactly what we're trying to do over here. So what Hesse's law basically says is if you go from A, which in this case is NaCl, to B, which is the dissolved NaCl, or if you go from A to B, or you go from A to C to B, the enthalpy change is the same. There is no difference. So in the context of this, if you go from NaCl solid, if you break it apart into its constituent gaseous ions, so if you make it like this, if this is what you do, this is called lattice enthalpy, as I mentioned before when I was explaining the terms. And then you hydrate these. This is enthalpy of hydration of the chloride ion and the enthalpy of hydration for the sodium ion. So whether you calculate the enthalpy of solution directly, or you first calculate the lattice enthalpy and then calculate the enthalpy of hydration for both the ions and add these two up, you will get the same answer. You will get the same final enthalpy. So that's why when in the beginning, I had said that enthalpy of solution is basically equal to lattice enthalpy plus enthalpy of hydration of both the ions. So this is a Hesse cycle, and this is what Hesse's law says. Now, in context of this question, let's figure out what's going on. Let's see how to do this. So you can see that they have given us the enthalpy of solution. We know what the enthalpy of solution is. We know what the lattice enthalpy of sodium chloride is. We also know what the enthalpy of hydration for the chloride ion is, but we do not know what the enthalpy of hydration for Na plus is. So this is what we have to find out. And let's do that. So we know that the enthalpy of solution is 4. We know that the lattice enthalpy is 790. And we know that the enthalpy of the of hydration for the chloride ion is negative 359. Now, in order to make this all simpler, I'm going to revert back to the word equation so that we can substitute the values and then rearrange the equation in order to find out the enthalpy of hydration for the sodium ion. So that is all this question is. If you have a firm understanding of the concept, if you know what Hesse's law is, if you know what these different enthalpies are, you'll be able to solve this question very easily. So enthalpy of solution is 4, and the enthalpy of solution is equal to the lattice enthalpy, which is 790, plus the enthalpy of hydration for the chloride ion, which is negative 359, plus the enthalpy of hydration for the Na plus, or the sodium ion, which we do not know, so I'm going to call it X. Now let's just rearrange this equation to see what X is equal to. So basically this is 4 minus 790 is equal to negative 359 plus X. So X is equal to 4 plus 359 minus 790. Now, which of our answers matches this? And that's right, the answer is B. This is the correct answer. So I hope you've understood this. I hope you've understood what I've done. If you don't understand what the Hesse cycle is, if you don't understand what enthalpy of or lattice enthalpy or enthalpy of hydration is, please go and revise that before you proceed on to further questions, because that is absolutely crucial to understand before you proceed on to higher topics. So I hope this video has helped you. If you have any questions, please drop a comment below or message me on my social media or send me an email. I'll be more than happy to help you. And until then, I'll see you in the next video. Thank you for watching.